This is experiment number 2. We are studying about electromechanical overcurrent relay. The aim of the experiment is to study the inverse trip time characteristics of overcurrent relay. The connections are, we are using the current transformer for here, the overcurrent relay. For that reason, 9 and 10 is connected to the CT terminal. This is 9 and 10. Through the CT terminals we are connected here. And then you can see here 1 and 2 is connected for alarm or IA. So 1 and 2 should go to the NO port. NC is shorted and ensure that both the kits are grounded. In all the setups it will be like this only, if not extra ground button will be there. Next, we need to select a flux setting. There are in the range of 0.5, 0.75, 1, 1.25, 1.5, 1.75 and 2. We have selected 1.25 as a flux setting, that is my set current, and TSM as 1. TSM we have chosen 1. It is going to vary from 0.1 to 1. I have chosen it as 1 year. So all these settings we have done in a set mode. You can see the toggle switch is in a set mode now, and variac is in a 0 position, and this time interval meter should be in the dim position. Once we have done the settings, what we need to do, we need to push this to switch to the test mode, and then we should inject some fault current. Anything it is more than my flux setting current of 1.25, relay will trip. If it is the same or if it is less than that, relay will not trip. So we have injected some fault current. We'll switch on the supply. And we'll press start button. Before pressing start, ensure that the disk is in the rest. If the disk is in the rest, press the test start. Here it will show the fault current. It is 3 amperes. That is more than my flux setting of 1.25. You can see the rotation in one direction. Once the relay will trip, it will rotate in the opposite direction. So this is my trip time, 10.75. And relay trip has been tripped, it will be indicated through the trip indicator. Once the relay has been tripped, press the reset button. Now you can see the disk will be rotating in the another direction in the slow way. Before going to the next trial, ensure that disk is in the rest, and again you inject still more voltage for the second trial, and that will be displayed in the ammeter, and note down the corresponding trip time. And the tablet column will be looks like this. The TSM is we have selected in our explanation as 1. Here it is for 0.9, and flux setting is 1.25, and corresponding fault current will note down, and operating time for that it will be recorded like this. And we are supposed to calculate the PSM. What is PSM? It is the ratio of flux setting multiplier, that is PSM is equal to fault current by flux setting. And we need to plot a graph, trip time versus PSM. The graph will look like this, operating versus PSM. This is for different flux settings. 2 flux settings we have chosen, 1.25 and 1.5 for TSM of 0.9. Like this we need to repeat for the other trial or other settings of a set current. Thank you.